Hello, and welcome back. Let's talk about DHCP attacks. Now, first of all, let's recap real quick what is DHCP. DHCP, or Dynamic Host Configuration Protocol, is a network protocol that automatically assigns IP addresses and other configuration settings to devices on a network, allowing them to communicate with other devices and access the internet. It simplifies the management of IP addresses by automating the process, ensuring that devices get the necessary information to function correctly on the network, without any manual configuration. When it comes to DHCP, there is a certain process that takes place, which is called DORA. DORA stands for Discover, Offer, Request, and Acknowledge. The first step is Discover step. When a device or client connects to a network, it sends a DHCP Discover message to find available DHCP servers. An offer is then sent, which is sent by DHCP servers, that responds with DHCP offer messages, offering an available IP address and other network configuration information. The third step is when the client replies with a DHCP request message indicating that it accepts the offered IP addresses, and the DORA is finished with acknowledgement step, which is when the DHCP server sends a DHCP acknowledgement confirming that the IP address has been assigned and the client can now use it. This process allows a seamless configuration of devices within a network, but it also opens opportunities for attackers to exploit weaknesses in DHCP. Now that we know how DHCP works and the DORA process that is used by DHCP server and client, let's talk about common DHCP attacks. The first one is DHCP starvation attack. This attack involves an attacker sending a flood of DHCP Discover messages to exhaust the available IP addresses on the DHCP server. The attacker spoofs multiple MAC addresses and sends repeated DHCP requests. Since the DHCP server assigns a unique IP to each MAC address, it eventually runs out of IP addresses. When the legitimate clients attempt to connect to the network, there are no more IP addresses available. The impact of this is that the legitimate users cannot obtain an IP address, which leads to a denial of service on the network. It disrupts network availability for other users or services, rendering them unable to connect to the network. Another attack that you will hear about is rogue DHCP server attack, and in this attack, an attacker sets up a rogue DHCP server, and a rogue simply means unauthorized DHCP server on the network. This malicious server responds to DHCP Discover messages faster than the legitimate DHCP server, tricking clients into receiving incorrect network configurations. The rogue server can provide clients with incorrect IP addresses, gateway information, DNS server addresses, or other configuration settings. The attacker may, for instance, provide the client with an IP address that routes all traffic through a malicious gateway, enabling man-in-the-middle attack. This could lead to data theft, surveillance, or the injection of malicious code into user sessions. Another attack is DHCP spoofing. DHCP spoofing occurs when an attacker on the network responds to legitimate DHCP requests with forged or malicious responses, misconfiguring the clients. So how does this work? Well, the attacker spoofs the response of a legitimate DHCP server, providing clients with false gateway or DNS information. This allows the attacker to direct traffic, control client network connections, or even prevent clients from accessing the network altogether. DHCP spoofing could result in man-in-the-middle attacks, where attackers intercept sensitive data or alter communications. Now, another attack is DHCP lease time manipulation. An attacker can manipulate the DHCP lease time, which is the amount of time that it takes for an IP address to be assigned to a client. Now, this works by setting a very short lease time, which ends up making the client forced to constantly request a new IP address from the DHCP server, causing unnecessary network traffic and potentially slowing down the network. Now, on the other hand, setting a very long lease time may prevent legitimate clients from receiving a new IP address when needed. This attack can simply degrade network performance, increase the load on the DHCP server, or prevent clients from renewing IP leases, resulting in service interruptions. And lastly, we have man-in-the-middle via DHCP attacks. Now, DHCP-based man-in-the-middle attacks occur when an attacker leverages DHCP vulnerabilities, which could be some of the vulnerabilities and attacks that we already mentioned previously, to position themselves between a client and the rest of the network, intercepting or modifying traffic. For example, rogue DHCP server attack could result in a man-in-the-middle attack if the attacker wants to do that. Same goes for DHCP spoofing. If the attackers provide clients with false gateway and DNS information, this could allow the attacker to intercept communication or redirect users to malicious websites without their knowledge, which falls under man-in-the-middle attack. And lastly, the last thing that we want to mention before we move on to the next lecture are protection against DHCP attacks. So there are a few things that we want to consider. One of them is port security. Enabling port security on switches is necessary to limit the number of DHCP discover messages or to prevent unauthorized devices from connecting to the network. DHCP snooping is a feature on managed switches that can monitor DHCP traffic and block rogue DHCP servers or malformed DHCP messages. You also want to have IP address reservations, so assign IP addresses based on MAC addresses to prevent DHCP starvation or rogue devices from obtaining IP addresses. Also, network segmentation is important, so you want to separate critical infrastructure components such as DHCP servers onto isolated VLANs or subnets to limit exposure to the attackers. And lastly, as usual with everything, you want to monitor and send alerts. You can use intrusion detection systems and prevention systems or some other logging tools to monitor DHCP traffic for unusual activities such as an excess of DHCP requests or unknown DHCP servers. Alright, so these are the measures that you can take to protect from DHCP attacks.